Hello and welcome to a video on problem solving part 4, brought to you by the Answer series. I've got two examples here for you. I want you to pause the video, I want you to try these, and then we'll look at them together. The first one says to you, what values should k represent so that the nature of the roots of the following two equations will be the same? In other words, what is the nature of the roots of this question? And that one must have the same type of roots. So let us have a look at the first equation. If I'm asked about nature of the roots, I need to work out delta. And remember, delta is b squared minus 4ac. So I substitute b squared minus 4 times a times c, and I get delta to be minus 11. If delta is negative, it means that the roots are non-real. Now the nature of the roots must be the same. So if the roots of this first equation are non-real, it means the roots of the second equation must also be non-real. So I take the second equation and work out delta from that. And I get k squared minus 16k, and delta must also be less than 0 because the nature of the roots must be the same. Factorize. You've got a quadratic with a positive k squared. The zeros are 0 and 16. Where is this less than 0? It's less than 0 there. In other words, when k is greater than 0, less than 16. The next example is quite a tricky one. They say to you, determine the range of this function. X is not equal to 0. Now that's because you can't divide by 0. And they tell you that x must be real. So the first thing I do is I take this equation and I multiply by my common denominator. So I multiply everything by x. I then set up the quadratic. So I put it in the form ax squared plus bx plus c equals 0. My a value is 1. My b value is minus y. And my c value is 1. Now, because they told me x must be real, that means I have to have real roots. And if I have real roots, delta must be greater than or equal to 0. So b squared minus 4ac must be greater than or equal to 0. Simplify, factorize using difference of two squares. I've got a positive quadratic. My zeros are minus 2 and 2. You want to know where this is greater than or equal to 0. In other words, there and there. So it's when y is less than or equal to minus 2 or y is greater than or equal to 2. And there's the range of that function, because remember, range means possible y values. Now, it might be of interest to see, if I were to draw this graph, it looks like that and that. Now, you're not expected to be able to draw this, but just to show you what's happening with it, the graph never exists between minus 2 and 2. So the graph only exists less than or equal to minus 2 or greater than or equal to 2. The last example has lots and lots of words. It is a distance, speed, time problem. And what you need to remember is that distance is equal to speed times time, which means that your speed is distance divided by time, or your time is distance divided by speed. I want you to pause the video. I want you to read this carefully. I want you to try it, and then we'll look at it together. Now this one is a tricky one. Because of the number of words, you need to read it very carefully, very slowly, and take it bit by bit. It is a distance, speed, time problem, so what I suggest you do is draw up a table with distance, speed, and time. So let's go slowly. The distance between Joe's house and the supermarket is X kilometers. So the first thing I can do is fill in X for the distance. He drives from his house to the supermarket at an average speed of Y kilometers per hour, which means I can fill that in. And remember, the time is distance divided by speed. So I've got a distance of X, I've got a speed of Y, which means my time is X over Y. Right, let's keep going. From the supermarket, Joe returns to his house along the same route, which means the distance going back is also X. At an average speed, 1.5 times faster than Y. So his speed now is 3 over 2 Y, 1.5 times Y. Again, I use this formula. So time is distance divided by speed. And when I divide by a fraction, remember I multiply by the reciprocal. So invert the fraction and I get 2/3, and I multiply by that. So I get 2x over 3y for the time. The question says to you, calculate the overall average speed. Now, to find average speed, you cannot just get the averages of the two speeds. It doesn't work that way. And the formula you've got to use is very, very important. So the average speed is the total distance divided by the total time. So the total distance he traveled was x plus x going to and from the supermarket. The total time was x over y plus 2x over 3y. Get a common denominator with those two fractions of 3y, and on the top you're left with 3x plus 2x. So at the bottom of this fraction you've got 5x over 3y. And remember, when you divide by a fraction, you're going to multiply by the reciprocal. So you're multiplying by 3y over 5x. The x's cancel, and you're left with 6y over 5. And the question said to you, leave your answer in terms of y. Now, if you want to check this one, it's a lot more difficult than the previous questions we've done. So what you would need to do if you wanted to check is assign a distance of x and assign a speed of y, and check and see whether those numbers fit in with that. And you can pick a number of different values and see if it does work. But the question did say, leave your answer in terms of y, which means that is my answer.
Check out the video description below for practice questions from our study guides. If you found this video useful, give it a like and subscribe to our channel so you don't miss any new episodes. Follow us on Instagram or Facebook to stay on top of the latest TAS news and launches. So that's it for now from the Answer Series, your key to exam success.